So our project begins with a Python environment provided by Pokémon Showdown. It's a online battle simulator for Pokemon battles. This environment will simulate Pokemon battles, and our goal is to train a reinforcement learning algorithm that can learn effective strategies within this setting. Um, so our goal, like I just said, is train a reinforcement learning algorithm that's capable of learning optimal strategies for Pokemon battles. This involves training an AI agent to make effective decisions based on current game situations. Since Pokemon battles are influenced by things like RNG and some other multiple complex factors, just a simple algorithm is isn't really going to work. So instead, the agent is going to learn by playing numerous battles simulated um, playing numerous simulated battles so that it can refine its strategy based on the feedback and observations it gets within each of those battles. And so in this video, I just wanted to go through setting up the local environment and then showing how we um, trained our model and then showing it, um, obviously just showing, testing the model and showing how many battles it can win. So to start off, I'm going to set up the local environment, Showdown. This should set up um, the local. Yeah, this is what it looks like. This is just a local environment, so there's not going to be any other users online. In a little bit, it'll generate players for our bot to play against, and in this little chat, we could go through and sort of view the battles happening, or we could watch a recording of each of the battles. So then, let me train our model. Yeah, and then our model is going to play against two different players. We'll just have a random player, um, which is just, I think it's already built into the simulator, but then we made a max damage player that will essentially only choose the move that outputs the most amount of damage. And so those are the two players that our agent is going to be playing against. So I'm just going to do the random start. Basically, all it's going to do is it's just going to constantly learn, just simulating a bunch of battles. And by setting this to false, it's just going to continue to train off of the previous model. Um, and once we're done running, I'm going to be able to go through and sort of pick and choose which model performed the best to where then I can, in this load file, I can load that model and then use it to test it against two players to show how well it does in battle. So should. So yeah, in the local environment, you'll see it starts generating games where I can show you. The agent will just go through, play a bunch of games. Each move it does, it'll calculate a reward so that it can just continue to learn to make more optimal decisions. But once that, we'll pull up the tensor board. Not entirely sure why, but every time I want to pull up this tensor board, I do need to install it every time. Install. So, so yeah, I will auto run for a while. In the past, we typically won't find a model that um, well enough until at least say 160,000 steps. So um, it's in about maybe 5-10 minutes. So it's been some time now um, to for that value, um, sort of like a 10,000 step mark. It's just that so start agent. So to find the first again. Um, this I have to go through and set up the local environment again. So just same all I did. We could only whenever we were battling against the normal or against the default player, the random, so we could get our model to do was winning 96 out of 100 matches. So our goal with sort of this method where we were saving each model and then it continues to learn itself. The goal is to sort of get past um, 96 win mark. So let's see if this one will do it. So we had a model at I think it was 160,000 steps that did get to 97 wins. So we'll see if this model does it as well. sure I do it right. This crash, no, it did not. Second, I try to fix it. Shoot, I forgot to change these. Now this max does not exist right now. This again. So yeah, this one did not reach that um, at 97 battles that we wanted, but we have noticed, if I guess deleted the tensor board, but that mean value to go above, or a model to go above, I think like we got to win 97 battles in a round with a mean, say it was like close to 41. Um, Taking too long to let the model run to probably reach that point. So just for show, I just wanted to show how the code works. In the next clip, I'm just gonna kind of go through same process, just show results for battling against a max damage player. All right, so my audio did not record for the second part, but um, just gonna do a little voiceover for it. In the second part, we were just gonna show basically doing same thing in the first part. However, in this one, we're gonna test our agent against um, the max damage player. All they do is they just selected the move with the highest amount of damage. Um, Weirdly enough, it's more difficult to beat a player like that, and so this was supposed to be a little more complex. Um, it introduced so in the first so in the, before I get into that, in the first part, we were mainly focusing on like single Pokemon battles that would teach the AI the basic mechanics. So stuff like damage calculations, type effectiveness, move priorities, and then once the agent sort of understood those basic mechanics, we then scaled it up to more complex scenarios in this second part of the video. Um, where the agent would encounter teams with multiple Pokemon. Also introduced status conditions like paralysis and burn. Um, and then I had to make like tactical decisions, like switching Pokemon or maybe sacrificing a Pokemon for a better matchup. And so over time, the agent is just going to improve its performance, sort of learning through trial and error, and it's going to iteratively improve its strategies based on each outcome or each of the outcomes from the game from each battle. Um, and it's using those observations and calculating a reward based on those outcomes to just continuously learn from itself to where it should eventually become pretty hard to beat. Um, I was just going to let the rest of this clip sort of play out. But basically, like I just said, it just going to go through, set up the local environment again, going to train train the model, um, where I think there was like a parameter where reset training steps or something like that was false. Basically, that's what um, is allowing the agent to learn off of previous models to hopefully improve upon itself. Um, so it's gonna let the agent run for a while. And then in the tensor board, whenever it's training, I'm gonna let that run until I find a value that I like. Typically, I think what we originally were waiting for was to wait until the value got above, like a mean value got above 20. That's what I was waiting for. But I think after running it for, I want to say like 20 minutes, um, it only reached a value of like 19.4, I want to say. Um, but when I ran that, that actually, weirdly enough, that model did perform the best. We actually, before we had a win rate of 67%, whereas what I just, you'll eventually see in this video, um, we actually got a win rate of 75%. So yeah, this is our Pokemon AI that we have taught to battle in this Pokemon Showdown environment. So I hope you enjoy.